Okay, this problem says solve for x where x is a real number. And I can see an integration over here. I will go through how to integrate that. Before I do that though, I want to point out a couple of things that you should be paying attention to. One is look at this guy's video over here. He goes through the problem. I'm doing a little bit differently. What he does, he uses the Lambert W function to do it, all right? Which I say you should be aware of that. However, at the school I teach at, we don't really teach that, all right? However, we do teach Newton's method, so I'll be going through Newton's method and talking about how to do that using Sage. But what I want to do is I want to go through the integration at the whiteboard. Before you do it though, what happens to a lot of students is they misread the problem. And I want to point out this is the differential is dt. So the variable is t in the problem. I'm holding x as some kind of an unknown to me at this point, some constant value. I don't know what it is at this point. So what I'll do is go to the whiteboard and I'll write down the integration. But I do want to remind you that this is an integration that I'm not sure if it's done in Calc 1 or Calc 2, but it certainly can be done in Calc 1 and Calc 2. So I'm going to write a general statement down. And the general statement is when you have something like this over here. All right, I know that's not the integration, by the way. And someone says, how would you integrate that? One is you can memorize it. I'm of the opinion that memorization is not an important skill set. What I'd be looking at saying, well, I really can't remember that. I'm just going to simply say y equals a to the x. I would get natural log of y. That would x ln a. I'm going to differentiate now. That's going to be 1 over y dy dx equals ln a. All right? Now dy dx equals y. Well, y is just a to the x, right? ln a. All right? So the question is, how do you go backwards on that? All right? We're really trying to go backwards. Well, to go backwards, I'm noticing there's a relationship between these two. So I'm going to say backwards in this one over here, just looking at it. I'm going to say it's a to the x over the natural log of a plus c. Now someone says, could you check that? Of course I can check it. How do you check it? You differentiate it. What are you differentiating this over here? Well, let's just go through that. If I differentiate that, what do I get? I get ln x times ln a over ln a plus 0. This cancels out. Friday is not 1, by the way. And I get what I want. So I know my antiderivative at this point. Now someone says, you know, I remembered that. That's good for you. If you don't, they're kind of easy to derive, all right? So what I want to do is I want to write their problem down. I got to wake my problem up because I look at the problem again. And this problem over here is they want to find out what x is. So I know their question is, can you find out what x is given that x is a real number? All right? So I'll write the integration down. It's going to be 0 to 2. And then it's going to be x to the t dt. And they tell me that's equal to 3. All right? So my first goal over here is just to write down the antiderivative. And it's a definite integral and put the limits of integration down. So what am I going to get? I'm going to get x to the t over ln x. What am I using? This up here. I'm not going to put the constant integration because in a definite integral, it's going to disappear. And it's going to go from 0 to 2, and this will equal 3. These are what t is, though, not what x is. All right? So let's write this down now. What are you going to get? X squared minus x to the 0 over ln x is equal to 3. All right? Now x to the 0, I'm going to say over here x is a positive number, and I'm making that restriction at this point. And what I'm going to write down now is this is x squared minus 1 over the natural log of x is equal to 3. This looks like a pretty tough equation to solve. And this is where I and the other guy differ in what we're going to do. He used the Lambert W function. I'm going to use Newton's method. And again, I would recommend looking at his work. It's good, and he goes through it. Right? Now, if I were going to use Newton's method, the first thing I would do is I'd have to do some preliminaries. And to solve this equation, what I'm going to do is I need to get this thing equal to 0. And the way I do that is just do x squared minus 1 equals 3 times ln x. And then I want to solve that for 0, and that's going to be x squared minus 1 minus 3 ln x equals 0. I'm going to call this a function. All right, that's a function now. And then the question becomes is, what are you doing with that? Well, if you're going to use Newton's method, it would be a good idea to get a rough idea what the answer is. And so I'm going to also indicate to you that, yeah, I mean, you can make a stab at it. I'm not saying you can't. And certainly, I know I'm going to say, you know, above 1, below something else. But you can always use technology like use Grapher or some application to graph out, all right, to get some kind of approximate solution. But let me point out what Newton's method is going to look like, and I'll write that as a function. Newton's method. I'll say it's a function of x. What's that function going to be? It's going to be x, my guess, minus the function evaluated at that number x divided by the derivative. And I'm going to code this in Sage. And I'll go through that too, all right? I do get an answer at the end of that, and the problem with getting an answer at the end of that is an approximate answer. So I'm not saying you get an exact answer. With the W function, you actually get an exact value, but it's actually a functional value. It's almost like saying, you know, it's the natural log of something. But the bottom line is you will get an exact value over here, but they're always approximating it. And our approximations are going to be the same we get in Newton's method. But I will go to that next. Thank you.